Hi, good evening, Faith. Thank you. Yeah. Okay. No problem. So everything is supposed to be for 1 hour, right? So both questions by presentation, we should try and make it for 1 hour. So just 1 hour. Okay. Okay. I'll try as much as I can. So when you're reading my um stuff bio, you said I should turn on my camera, right? Okay, I will. Okay, even during the presentation, let's see. Should we be able to do it?
Hello. Yeah, good evening. Thank you. I'm fine. 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 Oh, I'm on itself. Yeah, I'm trying to fix that now. Okay, I think. Okay. I think it's off now. Hello? Okay.
𝗓𝗓𝗡𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓 Now
Yes, I'm here. Wow. Thank you very much. Thanks, everyone. Thank you so much. In fact, I don't even know where to start, but thank you so much. I appreciate. I hope you guys can hear me loud and clear. Okay. Thank you so much. I want to especially thank 𝗓𝗓𝗘𝗡𝗥𝗓𝗓 and her team. Thank you, Testers Kota. Thank you, Faith, for everything, like following up with me and all of that. So I really appreciate you. I'm happy to be here, sincerely. I see the good work that your team and your community is doing. I'm so I'm happy, privileged to be here. Thank you very much. So today we'll be discussing something that is very dear to me, very dear to me. So I'll quickly share my screen and then so we can start. Okay. Please confirm if you can see my screen. Let's see. Okay, cool. Okay, so we'll be discussing this topic, identifying vulnerabilities and testing of security flaws. So I've been in testing for some time now, at least privileged to be here for more than 5 years, and sincerely, security for me is, I don't think it's very common amongst the QA community. And because all we do is just testing of functionality, unit testing, and test automation. And even if you go on LinkedIn, you get to see just people posting about AI, test automation, and all this kind of stuff. That's what we see regularly on LinkedIn. We hardly even see content that speaks to security. We always feel like security is for people that are strictly in cybersecurity, right? I've worked in the financial sector where we test an application, and then once we are done with testing the application, we move the application to the security team and say, guys, please do your job. We don't have functional testing. We've moved all our tickets on Jira. I've done our own. You can now do your own and revert back to maybe us or probably the company, right? But I recently found out now that as testers, there are certain things we can do. There are certain things we can do on our end just to help to minimize all of these flaws. So today we'll be discussing how to identify these vulnerabilities, and then testing for them, no matter how little, because our major goal as testers is to ensure quality, support the whole idea of quality. Although quality is not just on us alone, it's for everybody, right? But we can do something on our end. So today I'll be discussing that little thing that we can do as testers just to help to minimize the issue. I know definitely the security team, cybersecurity experts, they will do their job at the end of the day. But as testers, there are certain things we can do on our end. So that's what we'll be talking today. So before I start, I was just doing some research and I found this article online on this thing because I wanted to just speak to strictly Nigeria, right? So we can get to understand the importance of this topic. So many things have happened. Sometimes we don't even get to hear these things in the news, but if you don't research, you might not know. So based on my research, found out that in 2024, the fintech giant 𝗓𝗏𝗡𝗡 experienced a security breach resulting in unauthorized transfers. And then Sterling Bank also had their own fair share of cyber attack, where they had some financial losses of up to 1.2 billion. A lot of things are happening, and as testers, we shouldn't just focus on our own. We've done our job, we get our salary, and we go. We can also do something on our end. We preach a lot about non-functional testing, which security falls under that bucket, non-functional. But how many of us are prioritizing that non-functional testing? And so today we'll be discussing. So I'll be speaking from the angle of APIs. I'm meant to understand that this session is supposed to be for intermediate level. So I believe that as a tester, QA, if you're in testing and you don't know how to test APIs, I think it's something you need to start looking into, right? Because API testing is huge. It's actually really, really huge. It's something that can take your career from ground zero to another level, instead of just focusing on just the web and the mobile and the UI testing. API testing is a very, very great skill. Currently where I work, I just focus on APIs, but I've actually had the privilege to do mobile and web testing in the past. But API is so delicate, right? And you might be asking yourself, why should we test APIs? First of all, if you don't know what the meaning is, API is application programming interface. It helps the system, both the back end and the front, like it helps two systems to communicate together. Don't worry, we'll get there. But I'll just try and see how I can break it down, like two systems to communicate together. These days, companies don't even build, I got to realize that companies don't even build their APIs from scratch anymore. Like even if they want to build, let's say they have the intention of, initially they had like an intention of building like 500 endpoints to manage their system. They might likely just go for I don't know, just know that they might just reduce it and then purchase the other endpoints from other service providers, right? So that's just to tell you that API business is really, really huge. So companies just focus on that. They build APIs and sell those APIs. Now, because that's what we interact with every day. If you log into an application, APIs, you're communicating with an API. If you do a transfer, you're communicating with an API. You update your profile on Facebook, you're communicating with an API. That's things are happening behind the scene on APIs. And these days, attackers are not even looking at the front end anymore. They're going behind the scene to pick those APIs, right? They will go into the system like a 𝗓𝗟𝗔. They will go into the system, they will log into your application, they will register on your application, use their normal details, valid details, register on the system. But their intention is not always normal. They are always looking for ways to, when they have understood everything, they'll start fetching the APIs and they'll attack the APIs instead of the front end, because the front end can be managed. Front end developers are very good. They can always put validations on the front end. They can manage what we can see, as users. So APIs are really, really, really huge. Now, let's just look at some statistics. Like I said, API is really huge, right? So 83%, this was the research that was done by Akamai, 83% of all internet traffic they projected that it's going to be API traffic, right? That's just, can imagine 83%, if you're in school, normal Nigerian university, 80%, you're already like scoring A already. So they've already past average, like 83% of internet traffic is API. That's to tell you how heavy and important API is. And they also said that API attacks will become the most frequent attack vector. This was also done by Gartner. Then this one is also when I saw this, I was like, yo, this is it. And I feel is the truth. So stateofapis.com, they did like a research where they asked people, hey, how are you guys managing your APIs? How are you managing your APIs? What kind of testing are you guys doing on your system, right? So they found out that only 4% of respondents said they were prioritizing testing, like security testing in their APIs. The others were just doing functional testing, performance testing, unit testing. I've actually done performance testing with Postman too before. Beautiful, nice. You get to see all the graphs and everything. It's nice, right? So we tend to focus on the unit functional performance and other to automate them, and we are good. You know, posts are really, we've learned automation, but how far, like what are we doing? Are we testing for security? You know, so now just look at this picture. You can see that API is in the middle, and the web UI is communicating with the API. Mobile apps are communicating with the public APIs are communicating with it. Now they are sending data to backend data. They are sending data through the API, and then it's being received by the web UI, also by the mobile app, and then public APIs. You can see that this guy is just he's like the glue, super glue that like in between. He's the messenger, he's the glue. You can't pass me. You must pass me before you meet the other guy. You must pass me before. If you need anything, ask me. I'll get it for you. You know. And if you just check briefly here, you can see that I wrote a few things where I said APIs connect UIs to backend. They provide direct access to data, and they can easily be discovered. This one, easily be discovered. I know most of us, I don't know, if you're familiar with UI testing, you know that if you want to see your API, it's very easy. If you go on an application and then you want to get to see your API, it's very, very easy. Just go on the application, stay on the app, right-click it, inspect it, and click on your network tab, payload, and then you just see the URL there, the request URL. And that's the API, that's the endpoint. So attackers, they are very, very smart. They know how they can get it if they want. Like if they want to. They also have automated tools where they can use to monitor these endpoints. But just know that when you're testing an app and then you feel like, hey, nothing is happening, everything is fine, like nobody can see our APIs, is a lie. Like they can actually just right-click, inspect, check the network tabs, and get to see the API. So it's there. Anybody that wants it, they can always go there and see it. So how APIs get attacked? Now, so just look at this green, the middle, the first one, the web mobile app, like the middle column. Now you get to see that, let's just say an attacker would come, like I said, they'll pick your application. If it's a web or mobile app, they'll pick the application, sign up on the app, get to understand the functionality. Oh, this app can do transfer. This app can take pictures. This app can upload photos here and there. They'll get to study the application, right? And because they know that behind the scene, an API is what is powering the front end. So they'll get to try to understand the functionalities of the application very well. They'll look at it, explore the system, understand it, and then they will immediately they will just leave the front end and attack the back end immediately, right? They'll just go straight to the API, fetch all the API, and start doing wonders with it, right? They start attacking it. And what are they looking for? They're looking for APIs that are over permissioned. They're looking for APIs that return too much data. So when I say over permissioned, so there's some. If you're familiar with API testing, you know that we have different methods, post, patch, several methods that can do different things on an application. And an over permissioned API is ideally an API should speak to something. Like if this API is for creation of something, then it should be for creation. They should have restrictions to just do that particular action. But an over permissioned API, you get to see one API that you can use to create, and then same API, you go and just change the method. If you're familiar with Postman, change the method. Same API can now do let's say you want to do get, you can't fetch get again, and that's not how it's supposed to be. So each one should perform a task and do one thing, and then they will also look at the next thing. Like I wrote here, the attackers would also want to look at APIs that return too much information. Now, when I found this, then I was, as testers, we're always advocating for the users, right? So if I'm testing an application on the front end and then the error messages, let's say I'm trying to log in with an invalid password. So I tried, like before now, I used to tell my developers, let's make it friendly, make it so that the user will know what they've done if they've actually done the wrong thing. Make it friendly, but there's a limit to how we can go, because sometimes that's the fact that we want to make it friendly, make the system, like make the error messages, like that's what I'm speaking to right now, make the error messages friendly. You might be revealing so many things. So for example, when you say something like let's say invalid username, maybe you try to put something like that, accept a valid username, or let's say a valid ID. So, and then you now try to impute an invalid ID. The system returns invalid ID. Sorry, invalid ID, something. That's like giving an extra information to an attacker. If somebody wants to attack the system, it's a valid error message. But somebody that wants to attack will say, "Oh, this value is actually invalid." Then I can actually, try again and try and get a valid one. Or sometimes when you want to get your password, and then you impute like an email address that is not on the database. Sometimes some systems will throw an error, say something like this email is not in our database, something like. They'll just give you give you too much information, and then you say, oh, this one is not in our database. Ideally, you have to make it really short and try to confuse your attackers. Sometimes you can put something like email not found, or those kind of things, just so that you wouldn't be giving them too much of information, basically. So that's what I'm trying to say. And they also look out for they try to access unauthorized functions, which I've already spoken about changing the get, post. They look at those things. They also look at logic flaws. We talk about all of these things as we progress. So but they look at all of these things when they pick those systems. These are like the first few things that they check. And then once they see that, oh, I can do this one is over permission, this one they're exposing too much logic here, they started doing their stuff. And these guys are making so much money. It's not like it's like another business entirely. So people hack systems, and when they hack it, they send an email to the company, they tell the company, hey, this is what we found about your stuff, and then they'll start negotiating, and sometimes they pay them money for thousands of dollars, sometimes naira, sometimes they've already stolen a lot of things before even reaching out. So how can we identify these vulnerabilities as testers, right? How can we identify them? Just like I said, there's something we can do on our end. We're not the experts. We'll definitely leave the entire, the major raw and thorough work for the cybersecurity experts. But on our own end, there's something we can do. So there's something we call the OAPS 2023 API Security Top 10. So basically what this means is, so OAPS, first of all, it means Open Worldwide Application Security Project. So what it means is, so they're like a body, it's an NGO. They're always advocating for security. So they, once in a while, they come up with like a list of what they feel is, like major attacks on systems, globally. So they come up with like a top 10 list and try to advocate for people to, use them. At least when they use them, they know that, okay, it's not like we're entirely removing security, because definitely hackers will always find a way. But the essence of all of this is to minimize the issue, minimize it, and reduce it to the barest minimum you get. So this is the latest one. So the last release is in 2023. So they have like a top 10 list. So if I'm testing several APIs, and then I'm looking at the APIs. Because now I know this, I don't just test APIs blindly anymore. I look at them, I look at my APIs, and then I'm thinking, where does this fit into? This one is broken authentication. Is it unsafe? Is this? So, but I'll explain this top 10 for us so we can get to understand it. But this, for me, currently is my guide. This is what I use, and I would like to share with you guys, and so you can learn and also implement it in your various organizations. So the first one is broken object level authorization, which is BOLA. So I tried my possible best to just see how I can break this thing down for everybody to see with little small examples, so we can get picture it, right? It will not be nice for us to use a company's or an organization's endpoint to start doing some practicals on the call, but I'm just trying to give you like a mental picture of what it is and what you can look out for whenever you are working with APIs. So the first one says broken object level authorization. You can call it AKA BOLA. So what it simply means is can user A access user B's data, right? So the first one says this request one. So let's say my name is John, and I'm a regular user of a particular application, and if I go to my profile section, I can see my details, and this is my ID. So when I signed up on the portal, on the application, when I created my account, when I created my account, they gave me an ID. That's every system has an ID. If you create an account as a user on an application, you will definitely get your ID. You might not see it, but behind the scene on the database, there's always an ID to identify and to differentiate you. So, but on the back end, like if you're interacting if you're working with APIs, you will definitely see all of this raw data, like the IDs, reference numbers, and all this kind of stuff. So this is a GET request, and what it does is just to fetch data, right? If you understand APIs. So this get method, the essence of this get method is to, if you run it, you will see the data for this John that has ID 31111, right? So you get to see John's name, his city, if he's married, how many number of children, depending on the data that he added when he was signing up on the portal, right, or creating an account. Now, and for you to see John's data, you need to log in as John, right? You log into your profile, you log into the application, and then you get to see your data. So let's just assume this first request now. I'm logging in, so I'll need to log in as John, use my authentication to run this particular endpoint. And when I run it, I will see my data as John because I'm the owner of the account. I get to see it. Where we will start having issues is when I log in as John, run the same stuff using another person's ID, let's say Jane. If you run pass Jane's ID, and then if you use your authentication to run this, and then you see Jane's details, you say, oh, Jane is she's a medical doctor, she lives in Aja, she's here. That's a problem, because ideally you're not supposed to see Jane's data. Why? Because you're John and you don't have access. You're a user. You're not an admin. If you can see, this is /user profile. You're a user. You're not an admin. If it was maybe, let's say, the admin or the super admin, yes, we know that one. He can see because he has access to viewing all of these things. So because you're just a normal user, how dare you? Like, how can you? But it's sometimes you might feel like it's not possible. But through the API, sometimes all of these things are porous. But on the front end, when you pick up an application or a web app, the front end is always very difficult, because the front end developers, they'll put all the restrictions, they'll tell you it's hard to find all these issues on the front end. But if you're interacting with APIs, it's very easy. because most times developers are in a haste, they're always in a hurry, they're always, they can miss all these little details. And as testers, we need to be looking out for this. So basically, first one says can user A access user B's data. So ideally, when we are testing going forward, log in with your account and try to see if you can view another person's details. So I did for 3 requests. I did for John, I did for Sam, so I wrote here, authentication is not equal to authorization. That's it. The fact that you can log into an application like we've authenticated, you say okay, you're a valid user, you already created an account, you can log in. It doesn't mean that you have the authority to view another person's profile, or it's not, they are not equal to. So we should put that in our head, like authentication, it's not equal to authorization, right? So everybody should stay on their own. Jane should only log in with Jane to view her profile. John should be able to see Jane's profile. Next one says broken authentication. So this one speaks to weak password, weak authentication. So when we are testing APIs, we need to look out for weak passwords. We need to look out for weak authentication. No 2FAs, no captcha. So all of these can come in based on the business logic. But I will just dwell on no authentication. There are some APIs that when you're interacting with them, I've actually tested some APIs and then I'm like, what's happening here? Why don't we have authentications, right? Why would I just why did you make it open? And the developers are, oh, I'm so sorry, I forgot. And then he started adding ensure that our applications, our APIs are properly, they have the right authentications for them. We shouldn't just leave them open. And but sometimes it depends on the business. Some APIs, they will actually leave those ones open, based on the business. They will say this one, we know the reason why we're leaving it open, right? But at least be sure that they've given you the go ahead, or they've confirmed that this one is actually a valid use case. But ideally, it shouldn't be open, because once it's open, it means anybody can access it. Even if when you go live, anybody can pick it up and access it. Because sometimes when you don't authenticate it, you might feel like nobody can have access to it. And I wrote there, don't assume. Just assume that your APIs will be discovered. Don't ever feel like it will never be discovered. I've already shown us how it's obvious. Just right click. Let's say they've already used the system, they will get to see all of these things. So don't ever assume that your APIs can never be discovered. They will always be discovered. They know how to get it if they want to. Number 3 says broken object property level authorization. So this one speaks to 2 things. You have to look out for the ability to update. Let's focus on this one then before we go to the first one. This is one that says revealing unnecessary sensitive data. Now, like I said, all of these things is hard to find them on your front end, because front end developers, they will always want to minimize these things on the front end. But on the back end, things can go wrong. So let's look at this, the request on the right, the one on the right that says, please get API / v1 user 1111. So this is a get request, meaning when I run it, I should be able to see my data, right? And I'm a user. When I run it, I should be able to see my data as a user. That's the essence of this particular get request. So when I run it, I should see my data now. It's harmless endpoint, nothing, there's no issue. I run it, and then I'm seeing the 200 okay. Yeah, 200 okay, which means it went successfully. But if you look at the body of the, the response, you notice that this particular endpoint gave me my ID, which is 111, as you can see. It gave me my username, gave me my email, my country, and then it started giving me information about my administrator, the person that is in charge of my account. Started giving me the name of my administrator, even gave me the ID of my administrator. And it also gave me the name of my, even gave me the privilege. Like, so it means that there's a valid, so it means that this system has several privileges, and there's one called administrator in capital letter, administrator. Do you know that if an attacker sees this kind of thing, they can leverage on it, and use it to harm the company and hack the system? Ideally, this endpoint is supposed to just give me my data, my name, and just stop there, make my country, and that's all. But for some reason, it's giving me supposing too much data for me. Like, why? You get? So that's just the simple explanation of excess data exposure. We need to look out for these things. Now, let's go to the right, sorry, to our left. You get to see that this one is a part. So this one speaks to the first one, which says ability to update object elements. That's mass assignment. It means that there's a possibility we should check for the ability. Like, let's just see. So if this endpoint this patch request supposed to update, like it's meant to update the API, right? Now, but I am a user. As you can see, I am a user trying to access /user/111. I'm a user. I'm trying to update my, I'm trying to update my account. But for some reason, because let's say it's the same person that accessed this, and then he's trying to do the other one here, because he has seen that there is an exposed, privilege called administrator, he could come here and try it out, right? Ideally, what this guy should be using this patch request for would have been maybe to update his phone number, or maybe change his country or his house address, or all those minor stuff, because he's a user. But when there is data exposure issue, and then an attacker has seen some information that might help them, they might use it to, harm the system by coming here and then try to use the same user API to upgrade their privilege, right? So the combination of these two issues is what we term as broken object property level authorization. The first one speaks to mass assignment. Can I change things on my, change objects on my request? Can I just objects that I'm not permitted to use? I think I need to use that word. Objects that I'm not permitted to use, because sometimes as users we are permitted to do several things. So objects that I am not permitted to use, right? Can I do those actions? Like I said, ideally, this user is not supposed to be able to upgrade his, move his privilege to administrator. It's supposed to be the admin or the super admin that will come and upgrade somebody, not a user doing it for themselves, right? So that's just what this is about. The fourth one says unrestricted resource consumption, right? Unrestricted resource consumption. This one just basically talks about high volumes, how we're managing high volumes of traffic on our calls on our endpoints, and how are we managing large requests, so I'll just give us a few examples because we're all QAs and get to understand. So just let's say, imagine you are testing an application that has to do with like a file upload. On the front end, developers most times they will put this file should be maybe 25 MB or 30 MB. They will just put it on the UI and then you get to see, But because our focus is on the back end, which is the API. Assuming those restrictions are not there, an attacker might abuse it, and probably start uploading large number of files, and then over time it might increase the CPU of the server and all this kind of stuff. And it will now, let's say for a company that I'm trying to figure out like something that we can all relate with. Okay, let's just say for like a company that, like a video streaming company, right, that helps people to let you can upload your videos, you can upload like your videos online, and you can imagine an attacker uploading, large number of files, and over time it just keeps increasing the CPU of their server and all this kind of thing. And the company that owns the product might be like, why are we consuming so much space? Because they are consuming so much space, it might affect their bills, and they might want to pay more money, so this one is the ability of your API calls to, to receive high volumes of calls, large requests. So we need to also check for those things. And how can we control this? We need to ensure that they are effective controls. We need to put those validations on those APIs. This first one says lack of execution timeout. So imagine somebody trying to purchase something, or let's say trying to purchase something online. I'm trying to figure out like a simple example I can use. Okay, let's just say somebody is trying to change his password, right? He's trying to change his password, and you put your email, and then you get like an OTP, right? Like a 4-digit OTP code. Now, let's say you get it on your email or you get it on your phone number, like 4-digit OTP code. Now, because you're the owner of the account, you have your OTP, you can easily go there, put the right OTP, and then you go, right? That's the positive scenario. But let's just assume that somebody wants to manipulate that particular flow, where they will start imputing negative, like wrong OTP over and over again, over and over again, over and over again. Now, if there's no timeout for that particular action, let's say if the OTP is 4 digits, that's 4 digits would take an attacker 10,000 attempts, combinations to get. If it's 6 digits, it will take an attacker up to like 1 million attempts, like combinations. And they have tools that can automate all of these things in minutes. They'll gather all this data and push it. So the smart way to handle this kind of scenario is when a user has probably imputed, maybe after like 2 or 3 attempts, you can time them out of the system so they can request for another one, right? Because we need to restrict those calls on sensitive APIs. And we can't do these things alone. It's not like this session is just to create awareness, but some of all these OWASP stop them, it's not on us as QA, but we need to be aware, right? So we can speak about them to the people in the business or company that can move, that can pay attention to these things, right? So when they put like an execution timeout on this kind of flow, it helps us to manage the risks for those kind of, because attackers are, like I said, are always looking for ways to prevent, to attack our stuff and our applications. And mind you, I know I've been discussing about OWASP stop them, number 1, number 2, number 3, number 4. Like I wrote here that there's no one measure that can be 100% effective. So it's advisable to combine all of these measures to help our business. Now, for this kind of stuff now that we have execution timeout, let's say we've already done the broken object level authorization, we've checked that user A cannot. So we need to try and combine all of these things per se. That's what I'm trying to say. Like combine all of these things to be able to have an effective system running. The 5th one says broken function level authorization. This one speaks to abuse of API functionality to improperly modify objects. So it's just basically, so let's say we have like a post request. So this is user 311, that's the first user, and this is his profile, right? Now look at the second request. Second one says post API admin profile 311. That's the user. This is not the user. This is the admin, right? The third one says API super admin profile 311 user. This is, so the ability for a user, so this first guy is a user. The ability for this guy to use his own ID to run this second one and run the third one, there's a problem. Let's take a look at the first request, post/API user profile 311 user. So this is the valid user request for the user. Now, an attacker would want to come here and then just change the same ID, but they are changing this guy. They are putting admin instead of user. Now, if they're not, this guy is not supposed to be able to run this endpoint, to do anything with this endpoint, because 311 is not an admin profile. But if he can do it with his credential, then that's a problem. Same thing for super admin. If the same user, this guy that is 311, that is just a normal user, can change the URL and just add super admin and run it to do something on the system, then it's a problem. That means he can change a function. That's one example. Second example is, let's say a user, 311 user, can get his normal run the endpoint to get his details, and then the same endpoint, all he needs to do to change it to update his profile. That's not how it's supposed to be. So this particular OOPS 5 broken function level authorization just speaks to how sometimes developers are not paying attention to this, how they configure this endpoint. They just leave it open like that. So ideally, this one should just, this guy, if he's trying to run the /admin, he should trigger an error. If he's trying to run the /super admin, he should trigger an error. It should only work if he changes the ID to maybe to something what is valid for this guy, right? So we need to look out for these kinds of issues where users can replace a passive method. They can replace a passive method to get, put, post, delete. They can use one method and change it, or they can come and move, or they can change an object, which is like I explained here, changing user to admin and this with the same ID. So these are little things that we should be paying attention to. Don't allow users to execute unauthorized functions, basically. So if you're not authorized to do something on the system, then you shouldn't be allowed to do it. If you're a user, you log into your profile, you should be able to do request 1 because you're a valid user for that guy. Except this admin has 311 as his as his ID, then he can run this. But if he's not, then we have to. This user shouldn't be able to run this successfully. Same for this; it shouldn't be able to run this successfully. Okay. Quick one, let's go to the sixth one. Sixth one says unrestricted access to sensitive business flows. Yeah, this one is really this one I was trying to see how I can put codes to bring out the endpoints for this that can help us with this, but I just couldn't. But I'll just try and explain it. Unrestricted access to sensitive business flow. So it's about the risks of an attacker identify or exploiting API-driven workflows. Careless business logic can create opportunities for abuse. Now, when we build our products, when we build our systems, sometimes we want to help the masses. We are building products to solve problems, but behind the scene, attackers are using our genuineness, like the fact that we want to help people solve problems. They are using that thing to, hunt us and affect our system. So for us to be checking for this unrestricted access to sensitive business flow, it can be so many things, but I was able to pick out just a few. If you've tested APIs, you'll notice that sometimes our developers are always using incremental IDs, and that is not a good practice. Let's say I create my account and then my name Kingsley, and then I create an account. My ID is 1, 2, 3, 4. Another person will create his own. It will now be 5, 6, 7, 8. Or let's say they are only changing the last digit, 0001, the other one, 0002. Or it can even be OTP. OTP 1, 2, 3, 4. Next one, 4, 5, 6, 7. Or OTP 221. The next one, 222. The next one, 223. An attacker would look at that and you're just giving him too much information. You'll be able to use it. The second example says request new OTP after few failed attempts. So this one, when I was looking at the researching this, they spoke about Instagram where there was an attack some time ago where cyber attackers were looking at celebrities and they were looking at their account. So what they did then was they would go and act as a celebrity and get details, maybe the email or the username of the celebrity, and then they will go online and then try to change the password of the celebrity, right? And the celebrity will receive the OTP, right? They will receive the OTP, but because the attacker can't have access to that OTP, there's nothing they can do. So what they will be doing is, because if that endpoint doesn't have like a timeout, the attacker, like I told you, can guess those endpoints. So they can guess those codes. So let's say it's a 6-digit code or like a 4-digit code. Like I said, for 4-digit code, they'll be able to guess 10,000. For 6, they should be able to guess 1 million. So, but it's a normal business, good business flow. The company said, oh, if you need a new password, just put your details and we'll give you OTP, you continue. It's a genuine, very genuine business flow. But they forgot to put like a timeout on that particular endpoint. So an attacker was able to use it past multiple tries, and they use different codes like that until they finally got it and they were able to take people's accounts. So how they were able to resolve it, how they were able to resolve, or my suggestion to those kind of issues, like if you encounter them, is you try to, you can maybe restrict them after like 3 to 5 attempts, and then so that the other OTP would expire, and then they will have to request a new one again before they can continue. So all of those things that you're just trying, once you do those, put those logics in place, it will prevent preventing the attackers from trying. Most of them will just like give up on the whole stuff. But if you really open like that, genuinely business workflow, no problem. You just want people to retrieve their account. An attacker might use that particular business workflow and do some certain things. So, but like I said, we don't work alone as testers or QAs. We work with the business. So some of all these sensitive business workflows, we need to discuss with the business, and then we work as engineering, we work with them to be able to figure out all of these things. But because we know now, we can then come up with, say these things in our meetings, say, hey, this can go wrong, this can go wrong. But the business should be able to give us some of those sensitive business flows. And then we as testers to QAs, we can also try and advise based on our understanding of the system too. Number 7 says server-side request forgery. This one just basically speaks to how our application accepts URLs, right? So, and I'm sure most of us have tested systems where there's like an input field where you need to pass in just like a URL, right? So server-side request forgery, if we don't pay attention to those fields, we don't put proper validations on those fields, an attacker might go in there and input a very, they can, like for this one now, what they did was, this is just an example of where like they put like a local host to a, so this endpoint is to create a product, right? And you're expected to pass the URL of your product, maybe your shoe, your bag, or whatever. But you have to put it in URL format, for example. So what's happening here is an attacker is passing like a local host, web store, JWT secret. So what he's trying to tell this endpoint is go to the database, fetch the secret key, the JWT secret key, and send it to me to my local host, right? That's what the attacker is doing here. So if this particular URL has like a validation check already, it will know that this thing is a local host URL, and then it will trigger an alert like a validation error. So if a URL is supposed to accept LinkedIn URL, let's say you build a form and then you're asking candidates or people to pass in their LinkedIn URL, it should be LinkedIn. If anything, our developers, they need to write the code in such a way that if it's not linkedin.com, it shouldn't pass, because an attacker might just use that one field like that and go into the system and get data that they are not privileged and that they are not supposed to get, and to send them to go there. They have a lot of scripts they can write. This is just one. They have so many things that they can just write, and to just go to the database and trigger those things and send it back to them. So when you're testing, please pay attention to those kinds of fields, right? So 8 to 10, all of this one, I just combine them. Security misconfiguration, we don't really have any impact here as QAs, but it speaks basically about how these API servers are configured. It's more of like the technical leads and the whole developer lead. They're the ones that are the ones managing. We are not the ones managing those servers, right? So, but this one speaks to how are those servers configured? Are they configured well? Are they using admin as the username and password, which is wrong? They're supposed to use, the people that supposed to have access to the server, how many person have access to the server, does the server have rate limiting, so this one is just basically configuration, how they are configuring the API server. Number 9 says improper inventory management. This one is very, very important. Like, I don't know, sometimes it's hard for companies to keep track of their APIs and how far they've gone and what they have done. You see, they develop an API, they develop a product, they have a Swagger document that has all the APIs. But over time, as the system keeps growing, you notice that nobody's going back to those Swagger documents to update it. Sometimes developers will just pick up a new feature, they'll pick up something and they will just develop a new feature, and nothing is happening at the level of the documents, like the documentation. How are we managing our documents? Are we retiring some of the endpoints that we are no longer using? Some developers will join a company, and then when they realize that I can't do this, where is the API? They will create their own, and maybe there's another one running, there's a version 1 running already on the system. But because there's no proper way of managing all of these things, it just creates, problem. The company, they ask how many APIs do we have? Nobody can tell you. I think we have this and this, and nobody can tell you for the fact that we have this, and this is the number of APIs that we have, or saying something like how many version 1 that, or like there's no proper, I don't even like, there's no proper management. There's no proper way of managing all the endpoints. You see version 1 here, version 2 here, version 3 here. So as testers, we need to advocate for that, try and see how we can encourage the business to have a proper strategy on how they can manage their APIs. It should be up to date per time, because it helps not just testers, it helps security, to also help security team as well. And if we are no longer using like an endpoint, we should retire it, we should remove it. It shouldn't be on the live server anymore. We should, because the old one is already on the live server, and an attacker might pick that old one because that old one doesn't have some of the security patches anymore. They might be able to use it, and do something, or probably that one might even give them more information about our system. The last one is unsafe consumption of APIs. There's a lot of, like I told you, these days most companies don't build applications, like they don't build their endpoints from scratch anymore. They just purchase online. They just purchase from different companies, purchase the APIs. Now, as testers, when we're testing products that are from third-party applications, we should also treat them as if they are internal. Like, we should be very aggressive in how we test them. We test for all of this, look out for all of these loopholes, because sometimes those third-party endpoints might not be safe. We need to also have our standards and measures and look at them critically, so before we consume them. Because sometimes, the OWASP top 10, they found out that companies, because they feel, oh, this one is not on us, it's on another company, just consume it like that. They do not even do proper check. But because they feel like, Shebi is from this bank, it's from the other bank now, I'm sure they must have done, their QA must have done its job. No, because you guys are integrating into it, please pick it up, test it like it's your internal application, your internal endpoint. So lastly, these are just 10 better best practices. Number one says define your API process. This is very key. Know your API ecosystem. When you join a company, ask questions. How is our API doing? So I know sometimes when I join a company and then they'll be like, hey, leave the APIs. Don't bother about it. But let's try to see how we can get it to understand what's happening behind the scene. Get security and dev team talking, and that's a very good practice. When developers and the security team are talking, it helps. Everybody knows they can. This one can advise, the other team can also advise. Make documentation mandatory, like I said. Ensure that you keep updating your documents from time to time. Train API developers and owners, like advocate for training. Your API should have like a centralized API management. All of this is not, we're not the ones establishing it, but we can be like advocates for all of these things, right? Don't trust anything, like I said, whether you're internal or external, don't trust it. Don't assume that they will not put an invalid URL or invalid token or anything. Don't trust anything. Don't rely on your UIs for security. I'll keep hammering on this. Your UI and your UI front-end developers, they know how to put those checks. Authentication is not authorization. And let's try and see how we can automate all of these things before. Once we automate our APIs, put all of these things in place, it helps to reduce our work. So if you want to learn more, testing, how to understand all of this API security, and you can go on this portal, @𝗓𝗓𝗓𝗓𝗓𝗓𝗓𝗓 and see how you can get some trainings. All the trainings are free. They have over 100,000 plus students already there learning API security for free. So thank you very much. I appreciate. This is my email and my LinkedIn, and I hope to hear from everyone. So do we have questions? I'm here to answer them. Mm, exactly. Exactly. Yeah. Mhm. Thank you. Probably they understood everything, I guess, but I don't know. This serious. This serious. Like, okay, it might be too. Maybe they understand. Like, they understood everything that I said, or maybe, or maybe they're still trying to digest.
Yeah, I'm here. I think I understood everything he said. Thank you, Kingsley. I understand. Thank you. um, yeah, I have my own question like that. Yeah, I've been trying to have. Actually, I'm new on this app like that, Sha. So you said about this GET makes you to see more users. Like I want to know more about that. Like about that GET makes you to see more of users info on API,
That
I think.
you mean BOLA, broken object level authorization?
Okay.
Is that what you mean? So
Yes,
imagine,
yes, yes.
okay. So if you're testing APIs, log in with your credential, right? Let's
Mm.
say, testers quarter, they have an application like a mobile application. If you log in as a valid user, that's fine. You can see your data, your details. Now, that's with through the API, not through the web app, through the API. Log in, put
Okay,
your
okay.
application, you see your data, like your details. Now, should you do you think it's good for you to see like Fates or anybody or colleagues, let's say Moses Benga, like if you can see his details with your login, do you think
No,
is
no, no,
do you think
no,
is right?
no,
So when you're
no.
testing for that particular scenario, log in with your credential, put your details, log in and see your profile. Then go and pick somebody. I just pick another person's ID and pass the ID. Which don't change your credential. Don't change your login details. Leave it there. Your authentication is there. Leave it there. Just pick the other person's ID, pass it there, run it, and see if you get the detail. Ideally, it's not supposed to return anything for you.
Okay,
But if you return
okay.
something, then there's a problem.
Understood. Okay. Thank you, sir.
You're welcome.
Yeah.
When is ideal to venture? I think once you've learned your normal functional testing, you can write test cases, can look at your document critically and analyze it. Because that's one of the major skills of the test. I always say that. Once you can look at a document, analyze the document, write good test cases out of it, and you can just go through the normal essay like testing cycle, test plan, reports, all those things. And I think the next thing is API. Just pick it up and start learning different methods, so that you can, once you pick a web app and you're testing it, you already know how things are happening. You know that this bug is not a front end bug, it's a back end bug. Because from the I showed us how to see those APIs. You know that this one is a front end bug, this one is a back end bug. That's when you know the testers that are very good and the ones that this one they'll be testing web app, but they can tell this one is a back end and not, because they understand the logic behind this. So ideally, once you're done with all those normal basic stuff, please move to API advice. okay, I use this one. I use Postman to do my normal regular automation, like quick one. But we have in AppSec, we have like a free tool where you can actually use it to run. So this is it. I'll just quickly share my screen. This is like an AppSec scanner. Once you sign up on this, all you need to do, just carry your collection, pass it there. It will help you run the top 10 of all of those things I've explained. The system would quickly check all those things for you and give you a report, and then you just get to see it real time, right? So that's what I use for now. There's a paid version, but you can actually do some basic stuff with this. Yeah. Okay. Welcome. That's what I use for now. There are other more advanced tools, but you can start with that. You can start with the top 10 OAPs, top 10 that I just explained. You can start with that. You can pick the first one, try and understand. Once you understand what number one means, you can now test for it, like I explained to Joshua, I think. So you can use that as your first check. You can say, is this endpoint or set? Is it endpoint open to Ebola? Is there an issue like Ebola issue, broken object? Can I change the object? All those. That's why you need to understand the top 10 at least for a start. Can help a lot. Mm. Yeah, beautiful question. Beautiful one. So, like I said, most times it falls back to the developers. They will probably, like, imagine that when I explained the Ebola issue, where user A can see user B's data. That's not supposed to happen. So all they need to do is to go and put a validation. They know how they're the ones that wrote the code, so they will go back and put a validation that user A shouldn't be able to see user B's data. If he tries it, attempts to use it, then an error message should display, or they shouldn't be allowed. So it goes back to the devs most of the time, 90% of the time. Or sometimes too, like I said, like the one that has to do with logic, business flow, the business can sit and say, okay, how do we tackle this? Do we change the workflow instead of using this? Can we use, so it depends on the issue though, but most times it's on the developers. Really? Are you serious? Okay. Okay. I don't know. I think it's because I'm tired of hearing about test automation, AI, Cypress Postman, Cypress Playwright. I'm just tired of that. I've been in testing for, I should be 7 years soon. Tired of hearing all those things. Nobody is talking about security. Nobody is coming up to say, when they are teaching people, beginners, about software testing, they say, yeah, we have non-functional testing. You can use JMeter for performance. Who is talking about security? Nobody. All they feel is we leave security for cyber security people. Who is talking about security? So I'm just tired of the whole. So that's why when I found this, I was like, oh, this is my happy place for now. So I love. That's why I don't know. It just feels like it's contagious, but I'm happy. I'm contented. I really want to take this far. Exactly. Thanks for having me. I appreciate it. Thank you so much.
Oh yeah, oh yeah, oh yeah.
Oh, yes. Yes, Faith. Good evening. I don't know if Kingsley is still on the call.
I'm
So,
here.
all right. So I just wanted to ask. So basically, the examples you've made use of are mostly REST APIs, yeah? So, but my question is, can you apply this same knowledge to APIs of a different structure, say GraphQLs and all of that? Would that also
Yes,
fly?
yes, yes.
Okay. All right. Cool. Thank you.
Sure.
Oh, so I think after the whole discussion, I'll talk. Sorry about that. Please. No, it's not a question. It's not a question. I just want to ask you something, but after the discussion, please. Sorry for catching you. Okay. Actually, I want to say I'm actually new into testing, into this testing stuff. I'm actually a front-end developer before, so when with the what's it called next quarter for we beginners for tests. Okay, next month. Okay, next month it's okay. Okay, okay, all right. Thank you. Goodbye. Thank you.